Okay, section 6.6. Let's say what we're talking about here. It's called trapezoids. Trapezoids and kites. Look at that. Go fly kite. Alright? You ever hear that expression?
Yeah.
Alright. So let's talk about what a trapezoid is first of all. Let's draw a trapezoid before I start talking about what it is. What it is, that's kind of funny to me. You have no idea. Back in the day when I was young, guys that were real cool, instead of going up to somebody and say, yo, what's up, you would say, I don't know if they said yo or not, I can't remember, but they say, what it is, like that. It was like a 70s, it's kind of like a 70s thing. It's like, yo, what it is. I don't know. Just to be different, I don't know. People will make fun of you guys, too, in a few years on some of the stuff that you say.
That you laugh at
Yeah,
that we
what's up?
say.
Oh, I don't know. Oh, in my other class, they always say John, that John. And so I start saying that, and they laugh at me because I'm so old.
Say
And
John.
I just said it. You missed it. John. It's not a John.
Why
It's a
is it
John.
like
No, I'm copying it. Okay, so here is a trapezoid. Let's tell you why this is a trapezoid. It's a trapezoid because you have exactly one pair of parallel sides. Okay, exactly one pair of parallel sides. That means one side or one pair of sides are parallel. So what must be true about the other two sides? No, listen to my question. Okay. The definition of a trapezoid. The definition of a trapezoid is exactly one pair of opposite sides are parallel to each other. So there's my parallel sides. What must be true about the other two sides then? They are not parallel. Very good. Okay, they're not parallel to each other. Okay. If they were parallel, watch. If this side right here was parallel to this, and this top one and this bottom one were parallel to each other, we wouldn't have a trapezoid. We'd have a what?
Rhombus.
Parallelogram. Thank you. A parallelogram. Okay. So this is not a parallelogram. Okay, this is not a parallelogram. This is a completely different thing. It's a trapezoid, but it does have one pair of opposite sides parallel to each other. Does that make sense? All right, so that's really just the definition of a trapezoid. We would call the two parallel sides, we would call this the base of the trapezoid, and this other parallel side would also be called the base of the trapezoid. I don't believe if it's just a regular normal, I guess they do that. They say the non-parallel sides are called the legs. All right, so this would be a leg and this would be a leg. Now, if you know how we name stuff, remember how we had a little picture for parallelogram, a little symbol for parallelogram? We don't really have one for trapezoid. We'd probably just put trap. Okay, so if I call this, you make up one,
Yeah,
I guess.
do it like that, please?
Well, now let's put the word trap and put a little period right here. Oh, you are so cool, but we'll just write trap. So trapezoid, what? A, B, C, D. So you name it just like you normally would. You don't have to start at A. You can start anywhere, but make sure you go around the what?
Around the bend.
Around the bend. Around the horn, right. That's what I say. All right, so go around the horn. There you go. We good? All right, so that's what a trapezoid is. There's really nothing else real special about just a regular, normal, everyday trapezoid. But I'm going to grab another type of trapezoid, a special one, right there. Oh, how about that? Okay, so watch this. Here's a trapezoid right here, but this is a little bit more special. Oops, if I could grab it.
Yeah, it looks like the two top angles are equal and the two bottom angles.
Good observation. There we go. Yeah, very good observation. Now, this is a trapezoid, and we'll just do this. W, X, Y, and Z. All right. So here we go. Here's our two parallel sides. So those would be our bases. What about our legs? What do you think might look like on our leg? I can't even talk. What do you think it looks like with these legs compared to the other trapezoid that I did? Yeah, exactly right. Now, does that have to be true about a trapezoid? No, because look, this is not congruent to this, right? And the top and the bottom are definitely not congruent to each other. So the sides don't have to be congruent to each other or equal to each other to be a trapezoid, right? But on this type of special trapezoid, this is a very special trapezoid, this leg is equal to this leg right here, okay? You wouldn't be that trapezoid? Now watch this. What if the two bases, the two parallel sides, what if they were actually equal to each other? Would it still be a trapezoid? What would it be?
A parallelogram.
It would be a parallelogram. It wouldn't be a square. Not necessarily a square. Okay? Because a parallelogram, you can have a parallelogram that's not a square.
Really? Oh yeah.
Absolutely. I mean, almost all the parallelograms we've been dealing with, right? So,
Shear. Do 90.
a trapezoid? No. No. No, we'll just do that. See, that's a trapezoid. It's not a square. It's not a rectangle, right? But I'm sorry, I said trapezoid. I messed up. That's a parallelogram, all right? But it's not a rectangle and it's not a square, all right? So yeah, we can absolutely have that. But let's go back to this. I've got a trapezoid and I got my legs. The two non-parallel sides are actually equal to each other. Oh, by the way, what was I saying before? What if the parallel sides were actually equal to each other? Then it would be a parallelogram. Because remember we had a theorem that said if one pair of sides was both parallel and equal, then what is the thing? It's a parallelogram, okay? So if this was equal to this, it wouldn't be a trapezoid to begin with. It would have to be a parallelogram. Got it? So, but this time, we're not saying the top and the bottom are equal to each other. We're saying the two side ones are equal to each other. So we've had I gave it away. I did, didn't I? You already said it anyway, right? So you had a triangle with two equal sides. What do we call that? A triangle with two equal sides.
Isosceles.
Isosceles triangle. So we call this, what do you think?
Isosceles
An isosceles trapezoid. Very good.
Oh, I thought that
So-
was like a little.
So it's an isosceles trapezoid. All right? Because the two legs are equal to each other. Not the two bases, okay, the two legs. The two legs are equal to each other. It's an isosceles trapezoid. And you're absolutely right. Let's do this. Let's just scooch this down. Won't put it in the middle there. It's an isosceles trapezoid. That makes this trapezoid a little bit more special, okay? So let's talk about the angles. Brooks said the angles are equal to each other. Take a look. This right here is what we call a base angle. Why? Because it connects the leg to the base. And this is the other base angle. It connects the other leg to the same base. So those two are base angles right there. And on an isosceles trapezoid, now this is only true on an isosceles trapezoid, not just an everyday trapezoid. Okay, so if we had a trapezoid up here, this angle right here definitely doesn't look equal to this angle here, does it? All right, because it's not an isosceles trapezoid. But if you have an isosceles trapezoid, then what do you think is true about those two angles? They're going to equal each other. That's right. So we could say that angle Z equals angle Y if it's a isosceles trapezoid. Got it? What else do you think might be equal to each other as far as angles?
W and X.
W and X, absolutely. Okay, so angle W and angle X are equal to each other, so we could jot that down. So we could say angle W equals angle X because it's an isosceles trapezoid. Those are also base angles, aren't they? They connect the legs to the base. All right? Everybody good with that? Let's put something else in here. We'll do this in a different color. Let's put some diagonals. That would be a diagonal, and this would be a diagonal right here. What do you think might possibly be true about those two diagonals?
Oh, is the smaller portion twice as.
Nah, that was that other thing we were doing. What about this? Nah, it doesn't look like it bisects that at all, does it? That looks way skinnier than this right here. It doesn't look like they're perpendicular. What about the lengths? I thought you would get that right away. What about the lengths of those? Yeah, they're equal to each other. They're congruent to each other in length. Okay, this only works with what kind of a trapezoid? An isosceles trapezoid. So the diagonals are equal to each other. So WY is equal to XZ. All right? Everybody with me on that? We can put congruent here. And let's see what else might be equal to each other. I think we kind of covered it, to tell you the truth. Nah, there's nothing special about that particular point right there. I think we covered it with trapezoid and isosceles trapezoid. Let's do this. Let's do another trapezoid. In fact, I'm going to come up here. Did I group this together? No, I didn't. Figures. I thought I did too. I think I just copied it. Let's do that. Let's do that. Now I'll group it, and now I'll copy it. Okay. Boom. Alright, there we go. Watch what I'm going to do here. I'm going to find the midpoint of this segment right here. Okay? So, like if I scooch over about right there, you think that's the midpoint? Yeah. And what I'm going to do is I'm going to connect this midpoint to the other midpoint. Right there. So if you look at it, oops, oh, why do I always do that? Oh, I don't know why that thing goes around there. Why does that happen? I will. And then paste it again. Let's try that one more time. I'm not sure why that happens. But here's, I'll tell you what, let's do this. Here's a midpoint right there, isn't it? And then the midpoint would be about right there. If I connect them, hopefully, yep, perfect, right there. What did I just do? I connected the midpoints of the legs of the trapezoid, right? Because this is the parallel side, these are the non-parallel sides, and I connected the midpoint. So that means this segment and this segment is equal to this one and this one. Agreed? Now, what's kind of cool about this, I can't remember if we did this with a triangle or not. I don't know. I think we did. We kind of did this with a triangle. We call this thing the midsegment. The midsegment. All right, because it's a segment that connects the midpoints. All right, pretty good name for it, midsegment. But what's kind of cool is this. Let's instead of using letters all around this thing, let's just say that this is A, this is B, and this is C. Is that all right? What's kind of cool about this, and we did this with a triangle. I don't know if you remember. If we connected the midpoints of a triangle, we had a thing called a midsegment on there as well. And I don't know if you remember anything about it, but this is what's true. Watch this. This midsegment right here, that midsegment, which is B, right? I named it B, is actually the average of the two bases. So how do you find the average of two numbers?
Add them up and then divide.
Yeah, add them up and divide by 2. So there you go. There's a little formula for you right there. Now, if you don't want to use like B, A, and C, you could say this. We'll call this B1. And this is what most books would probably do. B1 for base 1, right? Capital B, and then, oops, not 1, but 2. Then B2 for that. And then mid-segment, you could just, whatever, just call it M for mid-segment or something. We'll actually just write it out. So the mid-segment, I'll be a little bit more general here. The mid-segment is equal to what? Using these letters now.
B1 plus B2
Yeah.
divided by 2.
B1 plus B2 divided by 2. Exactly. That's how you find the mid-segment. Pretty easy, huh? Let's stick some numbers in here and see what we can do. Let's say that's 8, and let's say that's 12. 12 looks good. Okay, so watch this. If I wanted to find the mid-segment, it's pretty simple, right? So the mid, we'll just call it MS for mid-segment. Is that all right? So the mid-segment, what do? 8 plus 12 and divided by 2. That's 20 divided by 2, which is 10. So that is 10. Simple as that. Now, it gets a little bit more difficult when they do this, when they don't tell you what C is equal to. All right, we'll put a little question mark there. Now, I know that you know what it is because we just had it there. But let's pretend, let's go through the process and pretend we didn't know what that number actually was, and we had to figure it out on our own. And they give you the A and the B, right. So they tell you that A is 8, B is 10, and they don't tell you this right here.
Just love it like an algebra problem.
Yeah, we just put it into the formula. All right, stick it in the formula. So mid-segment, do we know the mid-segment? It's 10.
Oh, 10.
Yeah, it's 10. Equals, okay, the two bases added up. Well, I know one base, right? 8 plus, we'll call it C, right? Over what? Over 2. And now you just do a little bit of algebra, don't you? Multiply both sides by 2, right? Multiply that by 2, so you get 20 equals 8 plus C. Subtract 8 from both sides, and C is 12. There you go. Wow.
Oh, was I right?
I'll tell you what. I'm going to give you some homework, but we didn't get to kites yet. Sorry about that. Oops, I almost dropped my papers. I'm going to give you the homework on the trapezoid part. Now, I'm not sure which numbers are which,
A couple
but
of announcements, please. Michael Buderick, if you would please
do as much as you
report
can.
to
It's
the
8 to
guidance
27,
office. Michael
and it's
Buderick to the
pages
guidance office.
440,
Also, a reminder, tomorrow is
441.
the last day to
Oops.
bring in fleece
440.
fabric for the blanket drive to help bring comfort and warmth
Do as
to
much
the young
as you
patients
can,
at AI
okay?
DuPont Hospital.